In this video, we want to talk a little bit about square roots. Let's start off with a very straightforward example, something like this. The square root of 144. Okay, so what this means when we write this square root symbol, it's like a backwards square, right? So what this is saying is what number squared equals 144? Okay. Well, hopefully we know our squares well enough to know that it's actually 12 squared that equals 144. So then going backwards from 144, think of it as a backward square. The square root of 144 is 12. 12. There we go. So it's like squaring, but it's going the backwards direction. When you see this symbol, there's actually a little hidden 2 right here telling us it's the square root. That'll make more sense when we do other roots like cubed root and fifth root and things like that. But there's always a little hidden 2 right there telling us it's actually some number squared that equals 144. Let's try a couple more. Let's maybe call this one A, and then we'll get to this fancy one here with the 64 y to the 20th. B, I don't know, let's try something like square root of 9 25ths. Okay, this is all inside the square root here. Okay, well, square root of fraction, we just take the square root of the top and the square root of the bottom. So square root of 9 is 3. Square root of 25 is 5. So there we go, 3/5. It works nicely the way we at least hope that it would, right? You might have something with a decimal like this. How about square root of 0.04? Okay, so try to do this kind of thing without a calculator. It's asking what number squared equals 0.04. Maybe you can guess it a little bit. Maybe you do want to break out a calculator. It turns out this one is 0.2. Okay, so just because we have decimals, it doesn't mean we can't still take square roots. It's no problem that we have fractions or decimals. How about this one? Square root of -16. Okay, this one's a little strange. Eventually we'll get complex numbers. We don't have them yet. So what this is saying is, what number squared equals -16? Maybe you're saying it's -4 squared. Well, -4 squared is -4 times -4, which is +16. Huh. Well, the only other option is 4 squared, but that's also +16. Right? So there's no way to get to -16 by squaring something. So then when we try to go backwards, it's impossible. So for something like this, for now, we just write not real, not a real number. Not a real number. Right? Eventually we'll get something that says, we'll get something called complex numbers, and this would turn out to be 4i. But don't worry about that right now. That's coming. All right, now we get to some variables. Let's try, how about square root of x to the 16th? This is asking what number squared, right? What number squared equals, or I guess what expression squared equals x to the 16th? Well, it turns out, and you may want to stop the video and think about this for a little bit. It turns out that this is, let's see, well, how about x to the 8th squared? Because this is actually x to the 2 times 8, okay, which indeed is x to the 16th. Okay, so this one would be x to the 8. Now, that's kind of tricky, and that's a hard way to think about things. This is fine though. A shortcut here, remember there's a hidden 2 here for the square root, and the shortcut, let's see, the shortcut here is just divide whatever number you have in the exponent here by 2 for square roots. And we'll talk more about that in a future section, but here we have x to the 16 divided by 2, x to the 8th. Much faster, much less brain power required. It's good to understand how it works and why it works with these steps here, but really In practice, you just divide by 2 because it's a square root. If this was a cubed root, you would divide by 3. Fifth root, you would divide by 5, etc. Okay, so this gets us to the one we're trying to do here. Square root of 64y to the 20th. Okay, let's break this into two pieces, right? Let's break this down into square root of 64 times square root of y to the 20th. You can do that. Turns out square roots can be broken up like that. Over multiplication. If that was plus, we could not break it up like that. If this was plus or minus between them. But since it's multiply, we can. Square root of 64 is, right, you should know that. What squared gives 64? Well, 8. I say you should know that. Maybe you don't know that. You want to get to know the perfect squares. I'll talk about that in just a second. Square root of 64 is 8. And then we're going to do y to the, remember the trick, 20 divided by 2. So this is 8y to the 10th. There we go, 8y to the 10th. Now, as I was saying, you should be really familiar with the perfect squares so you know how to go backwards. What I mean by that is, 1 squared equals 1, right? 2 squared, I'm looking at the right column here, 4. 3 is 9, right? 16, 25, 36, etc. Right? Get familiar with all of those, right? 6 squared is 36, all the way up to maybe, I'd go even up to 13. 13 squared is 169, right? Because we want to be able to see these over here and recognize what the square root of them is. So it's easy to square these numbers on the left. So this is 3 squared, 4 squared, etc. But you want to be able to go backwards and get back to back to 5, for instance, from 25. So I would say write those out all the way up to 13 squared equals 169 and get to know those numbers on the right so you can easily take the square root of them without having to break out a calculator each time. You don't want to have to break out a calculator for square roots. On any perfect square, I would say less than 169.